Okay, we're looking at surface area of prisms and cylinders in this lesson. Again, we've talked about prisms and their nets, and cylinders and their nets as well in the last lesson, and in probably in previous courses as well. Um, and so that's going to help a little bit. You don't always have to make a net of a three-dimensional object, but if you can, even if you can visualize it a little bit, it does help you to decide what shapes you have to calculate the area for. Because really, surface area is just the area of each particular shape. So first one here says Marcy works for a toy company that sells sets of painted blocks. The company wants to find out which type costs less to paint, so which has the lowest or least surface area. So just a reminder, prisms and cylinders have two congruent bases. Congruent means equal in shapes, in geometry. So they're equal, and a lateral area. And so with a prism, the lateral sides are rectangles. In a cylinder, it's just one rectangle that's wrapped around. Okay, so we're going to complete the chart here to compare these two shapes. This is a rectangular prism, or actually it's square. Yeah, square based because it's 5 times 5. So that's a square, not a rectangle. And then the other one is a triangle, triangular based prism, because those two triangles there. Even though there's rectangles on the side, they're not parallel to each other. This is a triangular based prism. This is a square based prism. Okay, so base area of the block. So basically we've got them resting on the base, the vertical here. So that's 5 times 5, which is 25. For the triangular based, we need to know the height of the actual triangles. You need to look for that little 90-degree symbol with one side. So the base is this side, which says it's 6. It's the same as this one up here. And then the height of that triangle is labeled as 4. So you can see it's a half times 6 times 4. Well, that's going to be half of 6 is 3 times 4 is 12. Then the lateral area, all the sides between the bases. Now, what they've done here is, yes, you could take each side, add them all together, but what they've done is taken the base perimeter and multiplied it by the height, kind of like what we do in a cylinder, because really when it folds out, these are going to be 4 rectangles, this one, the back one, and the left one, and so they all have a height here of 7, and so what's that perimeter when it's folded out into a net? So the perimeter of the base, either at the top or the bottom, there's 4 of those sides of 5, and then the height of that is 7. So 4 times 5 is 20 times 7 is 140. Okay. So then the total surface area, we have 2 of the base, so 2 times 25 plus that 140 that we just figured out. So that's 50 plus 140 is 190. Let's go finish off the triangular based prism. So what are those sides? So here the sides around the triangle, so you can look here at the bottom or the top, they're going to be the same. So that's 6 plus 5 plus 5. What's that? 16. And then the height there is 7. So 16 times 7 is, that's 70 and 42, so 112. Okay, then we're going to have 2 times 12 for the base plus 112. So that's 24 plus 112 is 136. So definitely smaller for the smaller surface area for the triangular based prism. And you can kind of tell, really, if those sides are 5s and it's kind of cut in half in a way. Now the volume's different from the surface area, but you almost have one less side for sure, right? Because well, you do, because this is 5 as well, right? And it's the same height. So this rectangle is a little bit bigger than one of them, but not big enough to compensate. Okay. So which has the less surface area? So 136 is less than 190. So the triangle based prism. Okay. So here we'll get into a cylinder, just like the net that we looked at in the previous lesson. So we've got a rectangle and 2 circles. The circles can't be on the same edge as each other, because that means they would overlap. So they've got to be on opposite edges. And so if this is up top here, this means it's a tall and skinny cylinder, right? It's going to look something like this. Not a very nice one, but it is, that's what it's going to look like. So Karen is designing a plastic wrapper for a cylindrical roll of R12 insulation. The surface area of the wrapper is 2,375 square inches. What are the width and height of the rectangular part of the design to the nearest inch? What is the width of the rectangle? So basically, we've given some hints here and some steps, but we're working backwards because we are told what the surface area is. Okay, so what's the width of the rectangle? So this width here, well, remember that is the circumference of the circle, because that's going to roll all the way along, right? It goes all the way around that circle. So circumference is pi times diameter, or 2 pi r. Well, we have the diameter, so we might as well just use that, pi times 14. And then let's calculate on our calculator. So pi times 14. I'll keep a few decimal places until we're done. So 43.9823. 43.9823. So it says so I'm keeping it there, but now I can round, let's say, to the nearest, well, nearest tenth makes that go up, so actually about 44 inches. Okay, but we may go back and use this unrounded. Okay, so then how can you use the formula for surface area to get the height? So remember, surface area for prisms and cylinders is 2 times the area of the base plus the lateral area. So here, this is 2 times pi r squared plus, then we need the circumference times the height. So the radius, so if we go back and look at that diagram again, our diameter was 14, so our radius is 7, okay? And then we've just calculated the circumference. This is where I'm going to keep it to 4 decimal places, 43.9823, 43.9823 times the height. That's what we're trying to look for. And we need to know surface area, but it was given to us. So again, go back and look. It was 2,375. Okay, so now let's do our calculations. So 2 times pi times 7. 2 times pi times 7 squared, because it's area. And there's 2 circles in the cylinder. So 307.8761 307.8761. Okay, and then this obviously we copy out. Okay, so typically when I show work, I don't keep all the units in here. The workbook is, but I typically don't, but just make sure at the end that you put them in. Sometimes when you put units in here, it gets really messy and confusing. So they've done it, but if you see me doing my own work, I probably won't until the end. That's when it's important. So now we have to try to get this term by itself. So we want to subtract that from the left. So 2,375, subtract the two circles is 2,067.1239. Oops, just forgot. My memory's not great. 1239. Okay, and now that we just copy out that 43.9823. Now to get h by itself, we have to divide this left side by that 43. Just copy that out, divide by 43.9823. So in your calculator, I've got that last number as the numerator, so then divide by 43.9823, and basically, so 46.99, so 46.999, which is really going to round to 47 inches, okay, when we round to the nearest inch. So that's a working backwards question. Basically involves solving an equation. So that's the end of this little lesson. It should be some review, right? Because you've been doing these for a while. Just the working backwards, maybe you haven't done so much of. So there's a little bit of a sort of a twist on what you've learned before. Okay, so work on the practice and then go to the next lesson.